So in this video, we're going to be determining if a function is continuous or not. And as you will see, this is not very complicated to do. It's pretty intuitive, actually. And this idea is actually important. It's easy, but it's important. So let me get in a graph, first of all. So let me paste in a graph. So my graph is over here. Let me scroll a little bit to get to that graph. So this is my graph. Let's say that I drew a function. Let me draw that in green on this graph. So this is my function. It's a random function that I just drew randomly right now. Kind of looks like a cubic function, but I just made it up right now. So this function is f of x. So let's say that I ask you the question, is f of x continuous? Question mark. So how would you answer this question? Well, what does it mean to be continuous? When a function is continuous, how I like to think about this, and this is pretty intuitive, this is how I was taught it, and most people learn it this way, is if we draw our function without lifting our pen, we know that our function is continuous. So if I had a function, right, or let's say I had a line, and if I drew this line without lifting my pen, this would be continuous. But if I draw it and then I lift my pen and then continue, I have this visible discontinuity. And so this would be discontinuous. That's the difference. So in this case, since I never lifted my pen, you don't see any sort of gaps or holes or jumps, we don't have a discontinuous function, so this is a continuous function. This is true. Very simple. This isn't a hard idea, as I mentioned before. Now let's look at an example of a discontinuous function, and I'll scroll up for that because I have a function up on top. So here's my function. So this, as you probably guess, is a discontinuous function. And that is pretty clear because we see this visible discontinuity right over here. So we're drawing our function, and then we have this gap, and then we continue to draw it. So we obviously lifted our pen. So we have a discontinuous function. This is say g of x. G of x is discontinuous. And in a future video, I will be explaining I will be talking about the different kinds of discontinuities, and that will really help you understand if a function or what it means for a function to be discontinuous, and essentially identifying the types of discontinuities. So another thing that I wanted to point out in this video is trying to connect this idea to limits. So let's say that I wanted to find the limit as x approaches this point right here, and this is 3. So this doesn't look like it's 3, but it is 3. So this is 3 right there. So let's say I wanted to find the limit as x approaches 3 for this function g of x. What would that be? Well, clearly you could see, as you know how to find a limit. We see that as we look at it from the left. So from this direction, we see that we're clearly, let me remove this green arrow. We're clearly approaching a certain point, even from the right, from this direction, and we're approaching the function value of 2. So that's our limit. This is equal to 2, right? Clearly that's equal to 2. So this point right over here, just to clarify, is 2. So now let me ask you a follow-up question. What is g of 3? What is this equal to? Well, this, if we look at this on our graph, we have a hole here. So this is not, 2 would not be the answer because this is undefined at this point. But the real answer is, well, 4, right? We have g of 3 equals 4. That's right there. So that's our removable discontinuity. Obviously, you don't know what that means. If you do know what that means, great, but I will be going over that in a separate video. So why did I write these two things out, right? They're clearly different things. Why do I need to write them out? Well, the thing is, if the limit as x approaches a certain number, in this case 3, for a function, in this case g of x, if this is not equal to the function value, right? So if this is not equal to the function value at what point we're approaching, so in this case it's 3, then our function is discontinuous. So not continuous. This is an indicator if a function is discontinuous. So clearly at this point, at 3, we have a discontinuity. So that becomes evident. So let me write that out in sort of general terms. So if I had the limit as x approaches a for the function f of x, if this is not equal to f of a, then we have this discontinuity. So discontinuity. So that's one thing I wanted to point out. This is actually really useful, and it's important to identify when a function is continuous or not. And it's also very important to kind of connect this to limits. And if you think about this, it's actually also very intuitive. So I hope you found this video helpful.